Deep inside every cell of your body, there are particles that shouldn't exist. According to everything we know about physics, they should have been destroyed in the first second after the Big Bang. They should be impossible now. And yet, they're there. Trillions upon trillions of them, right now, inside you. You are filled with violations of the laws of physics. Scientists call it the Antimatter Problem. For decades, it has been one of the greatest unsolved mysteries in the universe, and the answer might be hiding in your bones. Here's the problem. When the universe began, the Big Bang should have created equal amounts of matter and antimatter. Matter is the stuff you're made of: protons, neutrons, electrons. Antimatter is its evil twin, identical in mass but opposite in charge. Antiprotons, antineutrons, positrons. When matter and antimatter meet, they annihilate each other in a burst of pure energy. It's the most efficient reaction possible, 100% mass-to-energy conversion. So if the Big Bang created equal amounts of both, they should have destroyed each other completely. The universe should be empty, nothing but radiation cooling in an infinite void. No stars, no planets, no you. And yet, here you are. Somehow, matter won. For every billion antimatter particles, there was one extra matter particle that survived the cosmic annihilation. That tiny imbalance created everything that exists. But here's what makes this strange. Your body still produces antimatter, constantly. Despite antimatter's supposed impossibility in our universe, you are a small antimatter factory. How? And why? The positron inside you. The antimatter in your body is called a positron, the antimatter equivalent of an electron. Same mass, opposite charge. Positrons shouldn't naturally exist. They require enormous energy to create and annihilate instantly when they touch normal matter. A positron, loose in our matter-dominated universe, survives for microseconds at most. And your body makes hundreds of them every hour. Here's how. Your body contains a radioactive isotope called potassium-40. It's naturally present in bananas, potatoes, and most foods. You have about 140 grams of potassium in your body, and a tiny fraction of it is always radioactively decaying. When potassium-40 decays, one process it can undergo is called beta-plus decay. The nucleus emits a positron, a particle of antimatter shooting through your tissue. This positron immediately encounters an electron. They spiral toward each other, drawn by opposite charges, and then they annihilate. The mass of both particles converts entirely to energy, specifically 2 gamma rays shooting off in opposite directions at the speed of light. Right now, inside you, matter and antimatter are destroying each other. You are constantly radiating gamma rays from antimatter annihilation events in your own body. You're not the only source. It's not just potassium. The bananas produce positrons. So do Brazil nuts. So does your brain. When you get a PET scan at a hospital, that's positron emission tomography. Doctors inject you with radioactive glucose that emits positrons. The annihilation gamma rays are detected to create images of your internal organs. Medical imaging literally works by photographing antimatter explosions inside your body. But here's something stranger. You're also being bombarded by antimatter from space. Cosmic rays, high-energy particles from supernovae and black holes, constantly rain down on Earth. When they hit the upper atmosphere, they create showers of secondary particles, including positrons. About 10,000 antimatter particles pass through your body every minute, created by cosmic ray collisions miles above your head. You are filled with the impossible, and you're swimming in it. The deeper mystery. But this raises the real question: why does matter exist at all? If the Big Bang created equal matter and antimatter, and they all annihilated, how did the matter inside you survive? Something broke the symmetry. Something gave matter a tiny, crucial advantage. We don't know what. The asymmetry problem. This isn't a minor puzzle, it's an existential crisis for physics. The Standard Model, our best theory of particle physics, requires matter and antimatter to be perfectly symmetric. Every process that creates matter should create equal antimatter. Every reaction involving one should have a mirror involving the other. And experiments confirm this. In particle accelerators, we create matter and antimatter in perfect pairs. The symmetry is precise. So how is the universe mostly matter? There are three possibilities, and all of them are disturbing. Possibility 1. The rules change. Somehow, at some energy scale, the symmetry breaks. Particles behave differently than antiparticles under certain conditions. We've actually observed something like this. In certain particle decays, there's a slight asymmetry. Antiparticles decay at slightly different rates than their matter counterparts. This is called CP violation. But here's the problem. The CP violation we've measured is too weak. Way too weak. It can explain maybe 1/1000th of the matter-antimatter asymmetry we observe. Something else must be happening that we can't detect. Possibility 2. Hidden antimatter. Maybe the universe is symmetric after all. Maybe there are vast regions of antimatter out there, anti-galaxies full of anti-planets and anti-people, separated from us by cosmic distances. This is bad. If matter and antimatter regions existed nearby, their boundaries would produce constant annihilation, a detectable glow of gamma rays. We don't see it, unless the regions are so far apart that they've never made contact. But how would the universe sort itself so perfectly? Possibility 3. Something is missing. The most likely answer: we're missing something fundamental. There might be particles we haven't discovered yet, heavier versions of quarks or neutrinos that decayed in ways that favored matter. There might be forces we haven't detected. There might be physics beyond our current understanding. The matter inside you right now is evidence that our picture of reality is incomplete. The strange case of neutrinos. Our best hope might be neutrinos, ghost particles that barely interact with matter. Neutrinos come in 3 types, and they switch between types as they travel, a phenomenon called oscillation. What's strange is that neutrino oscillations don't follow the rules we'd expect from the Standard Model. Even stranger, we've never detected anti-neutrino oscillations at the same rate. There might be an asymmetry. Some physicists theorize that heavy neutrinos in the early universe decayed asymmetrically, producing slightly more matter than antimatter. These hypothetical particles, called Majorana neutrinos, would explain everything. But we've never detected them. They might not exist. The positrons annihilating inside you right now are tiny echoes of the biggest mystery in physics. What if we got it wrong? Here's the uncomfortable possibility. What if matter didn't actually win? Recent theoretical work suggests another explanation. Maybe there wasn't an asymmetry at all. Maybe the Big Bang created equal amounts, they all annihilated, and then, somehow, matter was regenerated afterward. This could happen through processes we don't understand. Energy could convert back into matter under certain conditions. Quantum fluctuations in the early universe could have spawned new particles. If this is true, then you aren't a survivor of cosmic war. You're a second draft. Matter remade. The antimatter energy crisis. There's another unsettling implication. Antimatter is the most efficient energy source possible. 1 gram of antimatter annihilating with 1 gram of matter would release energy equivalent to the Hiroshima bomb. A kilogram could power civilization for years. But producing antimatter costs vastly more energy than you get back. Current production methods are so inefficient that all the antimatter ever created by humans wouldn't boil a cup of tea. This means the antimatter inside you represents impossible energy, particles created by natural processes that we cannot replicate efficiently. The positrons from your potassium decay are cheap, but scaling that up, harvesting useful amounts, we'd need to solve the very mystery we're discussing, the ultimate question. And here's the deepest issue. If matter can be destroyed by antimatter, and antimatter still exists, then everything we know could, theoretically, end. You are stable because you're surrounded by matter. But in the cosmic scale, stability isn't guaranteed. The universe has surprised us before. The particles in your body, the normal matter you're made of, only exists because of an unexplained fluke, a cosmic accident, a violation of symmetry we can't identify. You are made of exceptions to the rules. And yet, here you are. Whatever the asymmetry was, it created you. Every atom in your body, every electron orbiting every nucleus, every quark bound in every proton, all of it is left over from an imbalance we don't understand. You are the beneficiary of broken symmetry. And the antimatter inside you isn't dangerous. It's too sparse, too quickly annihilated. Those few hundred positrons your body produces daily are gone in microseconds, their energy adding infinitesimally to your body heat. You've been hosting antimatter your entire life. It hasn't hurt you. It won't. Instead, it's useful. PET scans save lives by detecting tumors through positron emission. Future technologies might harness antimatter in ways we can't imagine. The impossible particle might become our greatest tool. And the mystery itself is valuable. The asymmetry problem drives some of the most ambitious experiments in physics. Particle colliders, neutrino detectors, spacecraft searching for anti-helium in cosmic rays. Every experiment is an attempt to understand why you exist. Because the question isn't really, why does antimatter still exist inside you? It's, why do you exist at all? And the answer, when we find it, will rewrite our understanding of reality itself. Right now, particles are annihilating inside you. Matter and antimatter destroying each other in tiny flashes of gamma radiation. It sounds dangerous. It's not. What's remarkable is that these impossible particles exist at all, that the universe somehow arranged for matter to win, for atoms to form, for you to be here wondering about it. You are made of cosmic leftovers, and you carry the evidence inside you. The next time you eat a banana, remember, you're adding to your body's antimatter production, the universe's greatest mystery, in potassium form. Thank you for watching. Don't forget to like, subscribe, and enable post notifications.